class. Today we're going to talk about Chapter 8, Section 1, Geometric Mean. And our objectives today are to find the geometric mean between two numbers, and then to solve problems involving relationships between parts of a right triangle and the altitude of its hypotenuse. All right, so let's go first ahead and talk about geometric mean. It's a proportion used to compare two equal ratios. And when we're dealing with this, we have means and we have extremes. So this is an extreme, and the x is a mean. And since we have x up here again, we have another mean, and then we have another extreme. All right, when the means of a proportion are the same number, so that's those two x's, this number is called the geometric mean of extremes. And so what this is saying is the mean is our altitude. And we'll talk about in a slide or two about what the altitude is. And so in this proportion, our altitude is used twice. So we want to think about, for example, if we had 1 over x and x over 4, we want to find that number x so that these two fractions would be the same. And so that if we reduced them each, that they would be equal to each other. So in this case, our x would be 2. You guys all see that our mean, our x's are both 2's, and if we reduce 2 over 4, that gets us 1/2. All right, so find the geometric mean between, oops, we missed something. Let's go back a slide. All right, so if we have proportions, we would cross multiply and set them equal. So we'd get x squared equals a times b. And if we want to find that x, that mean, to get that x by itself, we need to do our square root. So we get x equals the square root of a times b. All right, so now let's find the geometric mean between 8 and 10. So we're just thinking x equals the square root of a times b, and 8 and 10 are our a and our b. So x equals the square root of 8 times 10. Well, 8 times 10 gives us 80. And if we type that into our calculator, we're going to get a decimal approximation of 8.9. If we were going for the actual square root, we know that that could reduce to 4 times the square root of 5. All right, 2, find the geometric mean between 9 and 4. So we're going to, again, take the square root of 9 times 4. That gives us 36. And the square root of 36, oops, sorry about that, is going to be 6. So our geometric mean is 6. Now, if you're not sure about something, if you need more time to write things down, don't forget you can pause the video, rewind the video, do what you need to get all these notes down. All right, now let's talk about altitude. I know there's not altitude on your notes, so write this on the side somewhere. Altitude is a segment drawn from a vertex of a triangle, and it's perpendicular to the line opposite. So if we look here, we're going to do it from our vertex there, and it's perpendicular. So I'm going to put in a 90-degree mark. If we notice that in this, we are going to create two additional right triangles. Because we see we have a right angle here and there's another right angle on this side. So it creates two additional right triangles, and we're going to find out that those triangles are going to be similar to each other. So using the geometric mean with right triangles, if the altitude drawn is to the hypotenuse of the right triangle, so let's draw that in, and then the two triangles formed are similar to the original triangle and each other. So I'm going to just put in some additional labels. So our altitude we're going to label with H, and it comes down to point D. And now AB has been separated into two segments, and we're going to call one of them X and one of them Y. Now, this is going to come into play in our next few theorems that we're going to do, but I just want to put those in there so we see them right away. So if CD is the altitude to hypotenuse AB, then triangle ACB, so our big one, is similar to ADC. So now look at those and see how I'm lining those up. We have our right angle at C, and we also have a right angle on each side of D. We can also say triangle ACB, that's our large one again, is going to now be similar to triangle CDB. Now this is the one on the right side, so the medium-sized one. So we've compared our two new triangles to our large triangle, and then we also know that they are similar to each other. So we can say triangle ADC, so the one on the left side, is congruent, or means similar to triangle CDB, the one on the right side. If you're not sure that you see that, take them, draw them out separately, and take a look there. Pause it for you if you need to. All right, the geometric mean, the altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of this altitude is the geometric mean between the lengths of these two segments. So altitude drawn, just like we saw before when we discussed altitude, we're going to label it D and break this into X and Y and call the altitude H. So that's like what we saw in our last box, but the new thing, it says the length of this altitude is the geometric mean between the lengths of these two segments. So if CD is the altitude to the hypotenuse AB in the right triangle ABC, then here's what we're going to look at. Our short leg, oh, excuse my smartboard there for a moment, the short leg, and we're going to call that X in this triangle right here, to the long leg. So the long leg in that triangle is going to be our H. Now we're going to look at our other triangle, and we see our short leg in our triangle on the right is that H. And the long one there is our Y. So we're comparing our two new triangles, and we're setting up our proportion of short leg to long leg. Now, if you notice here, we have H in our mean spot. So we're going to have H squared equals X times Y. And to get that by itself, we're going to square root both sides. So we get H is the square root of X, Y. All right. Similarly, we have another statement here that says on the back side of our page, the leg theorem. So we have two legs, so we're going to have that and statement, as you can see on the bottom. The altitude drawn to the hypotenuse of a right triangle, it separates the hypotenuse into two segments. So we've created D and our two segments X and Y, and our hypotenuse H. The length of this leg of this triangle is the geometric between the length of the hypotenuse and the segment of the hypotenuse to the adjacent leg. Whew. So what we're saying here now is instead of comparing the long and the short legs, like we did back here, because it says between the lengths of those two segments, those are the legs. Here we're going to be doing the length of the hypotenuse and the length of the segment adjacent to the leg. So now we're going to see hypotenuse here and on the top on the other one. And now we're going to do it to the legs. So we're going to be doing it one to the short leg and one to the long leg. All right, so in our right side, our small triangle, we have our short leg. Oh, and we're going to look actually at the big triangle. We have our hypotenuse, which is C, to our short leg, which was B. And now if we look at our small triangle, our hypotenuse in our small triangle is B, and our short leg is X. So again, if we cross multiply and then take the square root, we get B equals the square root of C times X. Okay, now we're going to compare the hypotenuse and the long leg. So if we look at the hypotenuse in our big triangle, that's going to be C, and our long leg is A. And now we're going to compare it to the triangle on the right side of the hypotenuse. And the reason why we're comparing it to that one is because our hypotenuse is A. We want our diagonals to be the same thing. And then our long leg in that triangle is going to be our Y. Again, we see our means are the same, so a is the a. So if we cross multiply and do our square root, we find a equals the square root of cy. Now, those last two theorems, slightly confusing. We'll talk about them, I promise, when we get to class. So let's put some of this information to use. We have a picture here, and we have a hypotenuse, a long leg, a short leg, and then we have an altitude. That's where that x is labeled, and that's created two small triangles. So let's just draw out all three of these triangles so that we can see what we're looking at. So I'm going to draw my large triangle first. So I have y and z, and now my hypotenuse I see here is a 5 and a 20, so that's going to be 25. So here's my large triangle. I'm going to just put that right angle there for reference. So let's put our next triangle. This one is going to be this triangle here that I'm talking about. So our short leg is our x, our long leg is our 20, and our hypotenuse here is z. And now let's draw our small triangle, and now I'm going to draw this one here. Our short leg is 5, our long leg is x, and our hypotenuse is y. So now I can see I have three triangles, and we're going to compare them. And I'm going to go ahead and find one of the legs, and I can see here that in this triangle I have an x here and an x here, so that's going to help me set up my proportion. So if we set up this proportion, looks like we're going to do short leg and our long leg. So I have x in my medium-sized triangle and 5 in my smaller one. And then I have 20 in my large or my medium-sized triangle and x in my smaller one. So if you go ahead and cross multiply, we're going to see x squared equals 100. And if we take the square root, we get x equals 10. Now that we know x equals 10, we can go ahead and put it in to these triangles here. And now in my two smaller triangles, I see that I know 2 out of the 3 sides. Because these are right triangles, think back, yesterday we did Pythagorean theorem, so now we can use that to find our missing other 2 sides. So I can take 5 squared plus 10 squared from my small triangle, set that equal to y squared. So go ahead, pause the video, take a moment, find out what y equals. Okay, you guys paused and found that, and we got 11.2 for y. And then let's go ahead and do z with my medium triangle. So we have 10 squared plus 20 squared equals z squared. Go ahead and pause and figure out what that is. Okay, if you've done that, you find out that z equals 22.4. And now we have x, y, and z. So notice that we only need to use proportion to find one missing value. Once we found that one missing value, then we go ahead and we can just use Pythagorean theorem from there on out. All right, so let's go ahead and look at this problem here. I'm just going to move the triangle out of the way. Again, we're going to find the 3 missing values. Oh, it says C, D, and E. We're finding X, Y, and Z. All right, so let's go ahead and draw out our 3 triangles. So we have our large triangle. We have Z as our short leg. Y is our long leg. And our hypotenuse for this one is X plus 9. All right, we have our medium-sized triangle. This is going to be the one that's on the left side of our altitude that's been drawn. Our short leg is 12. Our long leg is our x, and our hypotenuse is our y. And our last triangle, our little one, which is on the right side of my altitude. My short leg is 9. My long leg is 12. And my hypotenuse is z. So right off the bat, I can see that z, and my last triangle here, I can find z easily. And so that's going to be a Pythagorean theorem. 9 squared plus 12 squared equals z squared. Go ahead and type that into your calculator and take a moment to find that. Okay, so you end up with z equals 15. All right, so I'm just going to draw that into, add that into my pictures. and here. Now, if we look here, we don't have other two triangles that have two lengths um, or a hypotenuse and a length. So we need to go ahead and set up a proportion. And I'm just going to use my small triangle and my medium triangle, because the very nice thing about this is that I have two lengths here, and I can set them proportional to the corresponding sides. So if I take my small triangle short leg to my medium triangle, and then I take my small triangle's long leg to my medium triangle's long leg, we see that my means are equal, the 12 and the 12. So now all I have to do is 9x equals 144. So see, in this one we don't even have to do square roots. So that's pretty great. And we end up with x equals 16. So let's go ahead and add that into our drawings. And I can see right here in my medium triangle that now I have two sides. So I'm going to do 12 squared plus 16 squared equals y squared. Go ahead and pause the video, get that figured out. All right, you guys paused and found out that y equals 20. I hope that you guys are able to see a little bit more clearly the three triangles and the proportions that we've been setting up. Here's our last one for today, and actually we are going to be looking for W, and here we see that we only know three of our lengths here. We know our altitude, and we know the hypotenuse. So let's go ahead and draw two triangles out. And in my triangle that's the left of the altitude, I see that my short leg is 24 and my long leg is the W plus 4. Right, and then we have my other triangle. We see that our short leg is W plus 4, and then, oh, excuse me, and then our other leg is 6. I have those backwards, short leg, long leg, but it's not going to matter because we still have our sides in the correct spot. So if we set this proportional, we have our 24, which corresponds with our W plus 4. And then our 6 goes on the bottom because it came from the same one there, and it's proportional with our other W plus 4. So here we're going to have to do W plus 4 times W plus 4, and then 6 times 24 gives us our 144. We're going to do some foiling here. So if you FOIL, W squared plus 8W plus 16 equals our 144. Move some terms around, W squared plus 8W minus 128, because we minus the 144, equals 0. Go ahead and factor that. Find what multiplies to negative 128 and adds to a positive 8. One's a positive, one's a negative. All right, so we're going to have W plus 16 and W minus 8. If we set both of those equal to 0, we get W equals negative 16 and W equals 8. And if we look back at our problem, if we put in negative 16 plus 4, we get negative 14. So that is not going to work, and W equals 8 is our solution. All right, you guys have the 8.1 worksheet to finish up, or to do and finish up for tomorrow. We'll see you guys then.